Let us move on to see the different systems. Those are used for word sense disambiguation. In the previous lectures, we have seen the resources, WordNet, and other resources. In this lecture, we are going to see the systems. So if you follow the previous lectures, we know that whenever we talk about systems, we'll be talking about four types of systems. The first one is rule-based or knowledge-based system, which is the older one. Then secondly, supervised systems, where we have the labeled data. When we talk about NLP, when we have the availability of human annotated data. When we don't have the labeled data, we'll be going for unsupervised systems, which will be based on the clustering. Then generally we'll be using mostly the semi-supervised systems, where we mix the supervised systems data. We start with that, then we'll be exploring that using unsupervised systems. So rule-based or knowledge-based, supervised systems, unsupervised systems, then semi-supervised systems. So let us start with a rule-based system. When we can lay down all the rules that are required for word sense disambiguation, or we have a dictionary definition or glossaries for all the different senses, then we can apply rule-based system. These are handcrafted methods that rely heavily on existing lexical resources, but now those are not available, but they will serve as the basic foundation to understand the method of word sense disambiguation. Now, one of such algorithm is proposed by Michael Lusk in 1986, which is known as Lusk algorithm, simplest Lusk algorithm. The core idea of Lusk algorithm is that when we have ambiguity for a word, we can choose the meaning or the sense which has the most terms in common with the context. What we mean by context? Surrounding words. So let us try to understand this with an example. The idea is that if you have a given word, most likely the word will have the dictionary meaning if the words surrounding this input are matching with the words which are given in dictionary as the definition or the sentence. For example, let us consider a sentence called he went to the bank to deposit his money. Now, where is the ambiguity? Bank. Bank has two meanings. One meaning is financial institution where the people can deposit money and withdraw the money. That is the bank, we know, bank account. And there is another bank, river bank, where we can go for a walk and have a pleasant evening or pleasant morning. So the target word is bank. Now, when we look into the dictionary has defined these two like this. Bank means a financial institution. A bank is a financial establishment where customers deposit and withdraw money. That is the dictionary definition. Then river bank, a bank is the side of a river or a stream. Now, that is the input, and these are the possible senses. Now look at the context words. What are the context words which are surrounding the target word? This is our target where the ambiguity is occurring, and the surrounding the words is went is one word, deposit money. These are the another words. Now, compare these with the glossary definition. When you compare this, here we don't have any common words in this sense. But when we consider this definition, uh, deposit is there matching, money is there matching. So it has two matches. But whereas riverbank doesn't have any match. So we say that this is more overlapping with this sense is more overlapping with this definition. So the LESC algorithm is built on the concept that the sense with most overlapping words should be chosen. This is known as LESC algorithm. We can put it that in an algorithm, you can understand it. Firstly, overlap will be assigned as 0, no overlapping. Then we take the context. These are the surrounding words. Once we take the context, we go to the glossary. We go to the glossary or the signature here. Then we look for the overlap. If the overlap is greater than the maximum, then we'll assign that as a maximum overlap. Then that particular sense will be assigned as a best sense. So this is LESC algorithm, which is known as simplifies LESC algorithm. What are the steps? Identify the target word and context, then retrieve all the dictionary definitions of all possible senses of that word, extract the context words, compare the context with each sense glossary, and select the sense with highest overlap. And the sense with maximum number of overlapping words is chosen as the correct sense of the target word. This is LESC algorithm. It was proposed in 1986, right? 1986. So this algorithm, simple LESC algorithm, remember you'll be doing a lab program on this LESC algorithm. What is the principle of LESC algorithm? Maximum number of overlapping words. The sense which has the maximum number of overlapping words is the correct sense. Where the overlap between the context words and possible senses or glossary or dictionary words. This is LESC algorithm. So Banerjee and Pedersen in 2003, they improved that. What they told is, instead of choosing arbitrarily the context words, let us use 5-word window strategy. Earlier, we have taken only 3 words here, right? As the context words, when to deposit money. But now, this proposal has made it mandatory to take 5-word window around the target. Now, if you see the around the target, 5-word 1, 2, 3, 4, and 5 went to the bank to deposit. Now, when we take 5 words, there will be more matching. So obviously, they measured the similarity using longest common subsequence, longest common subsequence between the word's context and its dictionary by taking 5-word window. In fact, this modification where we considered 5-word window and uh, measuring the similarity using longest, what is the sequence, longest sequence which has common, then the accuracy improved, uh, doubled almost from 16% to 32%. Now let us see another algorithm which is proposed after a decade of the LESC algorithm, which is known as Jaworski algorithm, proposed by David Jaworski. This is also a dictionary-based algorithm. Remember, these are all old algorithms. Now we are using machine learning systems. We are not using dictionary-based algorithms nowadays, but still there are certain areas where the people will be depending on the dictionaries. So this method is based on Rosette's thesaurus dictionary. If you remember in the previous lectures, when we talked about resources, earlier resource were dictionaries and Longman Dictionary of Contemporary English. The second one was Rosette's thesaurus. So In this thesaurus, it was there were defined 1042 categories were defined, and based on that categories of words, uh, this algorithm tries to disambiguate the given word. So this algorithm has three steps. Firstly, collect contexts surrounding words from the thesaurus. For each context word, which we also call a salient word, calculate weight, the probability, how many times that particular word wi appear in the category of the words. The probability of word wi occurring in the context of the thesaurus. That is the probability. And based on this probability, select wi, which is the maximum probability. Calculate the weight of the each salient word. Calculate for the given test set. Calculate the maximum weight and predict the appropriate category based on that weight. This is known as Yarsky algorithm. There is another algorithm which is known as structural semantic interconnections algorithm, which is we can call it as SSI algorithm. This is a graphical algorithm where the words are represented as a graph or as a picture rather than a graph. I prefer to use the term called picture. This is very high efficient algorithm, though it is not a supervised learning algorithm. This is a knowledge based algorithm, but still the performance is on par with supervised algorithm. This algorithm has two steps. One is initialization step, where you will assign semantic relations between the words, and then secondly iterative step, where you will be disambiguating till there is no disambiguation. This is proposed by Navigli and Velarde. Now see, this is one of the here the word of ambiguity is bus. So bus has two meanings. One is transportation bus, another is computer bus, where we have the cable or connection. So here there we have no uh, semantic relations. This is a kind of relation. This is has part composition. And if you see the bus of transport sense, the words which are related to our context words are passenger, roof, school bus, plate glass, pane, window frame, window to, vehicle, express, instrumentation, transport, traveler, public transport. These are the different words, and they are all connected to each other. Each other. So bus is glossary, different words. Then coming to the computer connection, there also you have different words connected together: electrical device, calculator, wiring, computer, machine, conductor. So what we do is in this uh, semantic graph, we'll be choosing from the given sentence which graph has more number of context words that will be chosen. Now we can put that mathematically. Let us say lexical context is list of all words that appear in the context. For example, here we have seen in the graph all the words. So T1, T2, T3, so on. For example, bank. The sentence is the bank raised the interest rates. So we want to understand what is the meaning of the bank in this context. So here T1, T2, T3, T4 are bank, raised, interest, rates, removing all the stop words, keeping all the main words. Then structural specification. S1T, S2T. This is the target word. What is the target word now? Bank is the target word. So one target is financial institution, another target is side of a river. So then we will see what is the semantic context. The semantic context is, now the context words are raised interest rates. So the semantic context I is S raised, S interest, S states. Then fourthly, we'll have the grammar, semantic grammar, which we studied in syntax parsing. Grammar will have edge labels, non-terminals, starting symbol, and production rules. So we'll have that analysis and we'll analyze all those relations and we'll calculate what are the, how many relations it has, which word has more relations. For example, if you have here two ST1, ST2, which has more relations in the given graph, that we will analyze and we'll choose higher likelihood S for that. So this is known as SSI algorithm, structural semantic interconnections algorithm. So if you take our bank, the semantic context is raised interest rates. When we compare from the semantical structure, this refers to more financial institution because it will have more links in that graph. Then Wikipedia versus WordNet. When we use Wikipedia, though it is not a resource, but still like WordNet, we can use Wikipedia also. And from the Wikipedia, there is another algorithm, WikiRelate. Now we will not see it, but WikiRelate, it uses the taxonomy of the Wikipedia, how it will divide the words with same meaning. So that algorithm is known as WikiRelate algorithm.